Okay, welcome to note set M02, where we continue our discussion of MATLAB. And so here we'll be talking about variables, expressions, and characters. And this is pretty much covered in the first chapter of the Not Required book on MATLAB, the one by Stormy Attaway. So, I mean, as I said in the syllabus, that book's not required. If you've never had a programming class before, it might be worthwhile getting that book. But pretty much these notes will give you the main things that you need. And really, as I said before, the best way to learn MATLAB is to just dive in and play around with it and explore. So we already saw in the first set of notes concept of variables and how we can assign values to variables, but we'll give a little bit more detail here and make it a little more formal. So as we saw already, a variable just has a name, and there's a few limits on what you can use for variable names, but it's not too restrictive. We'll cover that in just a little bit. But basically it allows us to store numbers, and which we've seen already, and characters, which we've not seen already. So MATLAB does allow you to work with characters as well as numbers. And the whole point of assigning these to a variable is that it's kind of a storage place. It holds it and allows us to use it in the future. Unlike a calculator where you punch in a bunch of things and you get a number and then it's gone, you can store it to a name and then recall it by just using that name again. And sometimes you don't even know what the value of that variable was that you just computed. You just go ahead and use it in something else. So to create a variable, as we saw, and last time we saw x is equal to 5, and that created one. So in general, you don't have to just put a number there. You can put whatever your variable name is. You get to choose that with only a few restrictions. And we can put some sort of MATLAB expression here, some string of commands that does something, some sort of computation if we want. So here's a simple example. You can tell that I took this from the book and not on my own, because if it were my own, I would have put 5 there, not 6. So we've now assigned 6 to the variable called mynum. And in math, when we talk about a variable, it's something that we don't know and we're trying to find. Or we're letting run over a range of values. So like f of x is the variable. In MATLAB, a variable is actually something that we have assigned a number to. Now, it's variable in the sense that I can reassign that, anything else to mynum. And we can put any valid expression in the assignment. So once I've defined mynum, I can reuse that. So that now holds the number 6. If I had assigned some other number to it, it would hold that number. So now I'm going to do whatever's in mynum minus 2. And I'll call that RES, maybe to stand for result. And so we see that the result of that is indeed 4. And if you look at these two examples, both that one and this one, MATLAB echoes back the result with the name of the variable and the value that it has. But sometimes we don't want to do that, especially if we're writing a program that's a whole sequence of a bunch of computations and assignments. We don't want to have this all spewing out, especially if they're intermediate results that we don't care about. And so we will often put a semicolon at the end of our expression, and that will suppress the echo. So if it's just a single number being assigned, no big deal. But we'll see in the next set of notes that we can assign large arrays of numbers to a single variable. And so if you've got hundreds or thousands or even millions of values being assigned, if those were to be echoed back, your computer screen would be filled over and over and over and over with the spewing out of these numbers. So using the semicolon is kind of crucial in those. So if you reassign a new value to a variable that you had previously assigned something else, that old value is lost. So I think that's pretty clear. So here again, assigning the variable mynum, assigning it the value of 6, and we can use the variable even in a reassignment to itself. So, in a math equation, if you had x is equal to x plus 1, that's a weird equation. But this is not an equation. This equal sign is an assignment. So what we're saying here is that we're going to evaluate everything on the right-hand side first. So at this point, mynum is equal to 6. We're going to add 1 to it to get 7. And that 7 gets assigned to the variable mynum, and we see that echoed back. So keep in mind that this is not setting up an equation, it is an assignment. Variable names already alluded to the fact that there are some rules, but very few restrictions on them. Just good style is to use names that kind of make sense. You don't want to just litter your code with things like X, Y, Z, unless those make sense. If you're doing something in three-dimensional space, then maybe X, Y, and Z make sense. But you want to use a name that will tell the person trying to understand your code, help them understand what it is that you're trying to do. But on the other hand, you don't want to make them really long, because then it's difficult to type them in and keep track of them and all that. So there's a more general concept in MATLAB called identifier names. So identifier names include variable names, which we're talking about here, as well as function names. So later we'll be talking about scripts and functions. And so the rules that describe what we can do for variable names is more general, applies to function names and so forth. Any identifier name must begin with a letter, cannot begin with a number. But after you've started with that first letter, you can have numbers, you can have other letters, and you can include the underscore symbol. But you cannot have a space. So as soon as you hit the space bar, you're done with that name. There is a limit to how long you can make the name, and if you type at the command line name length max, it will tell you how many characters you're allowed to put in the name. I'm guessing that this is maybe platform specific, which is why they have it possible to determine by a variable or a command rather than that if my guess is that if it were just one fixed number, they would just say, this is the number. I don't know. Or maybe it changes. They upgrade it from version to version. Don't know. Names are case sensitive, so be careful using uppercase and lowercase things. Those will be different from each other. So there's some words that are not allowed. So MATLAB calls these keywords. And if you go to the command line and you just type is keyword, it will give you the list of all the words that you're not allowed to use by themselves as an identifier name. Now, MATLAB has a bunch of functions that they've written for you to use. So, for example, there's one called FFT, which is popular in signal processing. You should not use that name, but if you do use that name, it could very well prevent you from using their built-in function called FFT. So you should be careful. And before you go using a name for a function or a variable, you might want to check to make sure that there isn't a function already defined with that name. That's one way that people end up having problems with their code. Well, we've already talked about whos. So we've seen that the whos command gives a list of variable names and also gives some details on those. There's a shorter version of it that's just called who, and that just gives you a list of the names in the variable, or names of the variables in the workspace. It doesn't give you any of the details on them. So the details that whos gives, we've already seen, gives you the names, but also gives you the number of elements, the number of bytes, the class, which we haven't really talked yet about, but we will, and then attributes, which we also haven't talked about, but we'll talk about later. We've also talked about the command clear and how you can use it to clear all the variables, or you can just put in specific variable names. And you can see here that I can't spell. Well, I can spell, I just can't type. So let's talk about the different variable types. These are sometimes called variable class. And there's a few types of variables that we need to know about. So the first and probably the most important, the one that's used the most often, is called single precision and double precision. So, if you've been taking courses in microprocessors or digital logic, you probably learned a little bit about how computers represent numbers, and you probably talked about fixed point and floating point. So single precision and double precision are both what we call floating point representations. And so, if we're trying to represent, hold on, I'll try to. Okay, I had to stop and get that phone call. Sorry about that. Downside of doing these recordings at my home. So as I was saying, single precision, double precision, these are floating point. So basically, when we're representing numbers that can have decimal points in them, these are the forms that we use. So double is the default, so that basically gives you the maximum amount of precision. So single precision and double precision, two different levels. Why you would want to do single precision might just be to try to emulate how numerical computations would work if you were trying to develop an algorithm that would work on a computer that's limited to single precision. Something like that. And as we already saw, when we run the whos command, it lists what the class is. So what is the precision that numbers are stored with? Well, we can get an idea of the precision of the storage of double if we just type EPS at the command line. That's going to give us the distance from 1 to the next larger double precision number. And so basically the next one is going to be 1 plus 2 to the negative 52. So you can see that the resolution between adjacent representable numbers is pretty fine. And so that's a measure of the precision that we're able to represent this to. Now, despite the fact that it's represented with such fine precision, which means potentially a large number of digits, so if we were to represent pi, for example, in double precision, it would have a large number of characters. But we don't necessarily want all those characters to display on our screen when we ask to see the answer. So MATLAB will display numbers in a variety of different formats, and the next several slides will give you some details on this format command that you can use to change how the number shows up on your screen. So to give you information on this, I just went to the command line and I typed help format, and this is what was spewed out, this and then things on the next several pages. I split it across a few pages. So it tells you that format is a command that allows you to set the output format. So output just meaning display. It tells you that the default format for float variables, whether they're single or double, is what MATLAB calls short, and we'll see short in just a little bit. It's also telling you here that this is only changing how numbers are displayed. It doesn't change at all how computations are done with those numbers. So despite what you set for format, if you've got a double precision variable and you're computing with that, it's being computed with double precision representation. And then this part down here is just talking about some aspects of format in the context of integers. And we haven't really talked about the int8 yet, but we'll be talking about that in respect to how we represent integers. Continuing with what spews out when we type help format, this is just showing the different ways we can change the format. So if we type format and then follow it with the word short, basically we'll get a fixed point format that just shows 5 digits. And you can see all these different things. So we can even get it to do floating point display. We can get it to do engineering format where the powers that are used in the floating point format are multiples of 3. So that's consistent with things like milli, micro, kilo, mega, things like that. Excuse me. And then the last bit that comes spewing out when you type help format is a few other things. So you can show things in hexadecimal format. To be honest, I've never used that. Sometimes we only care about, in a big array, we want to see what values are positive, what values are negative, and what values are 0. So there's a special format for that. If you're doing financial computations, you can put it into a form that will be convenient for showing dollars and cents. And this one's kind of cool. It will give you an approximation, a rational approximation of irrational numbers. So you could put it into the rational format and then type pi, and it will give you some ratio of two small integer, ratio of small integers that will approximate pi. Also, you may have noticed when you're doing MATLAB and it echoes back your result, there's a lot of space there. That's what's known as the loose format. You can put it into compact format and it will suppress all those extra spaces between there. So that's format. So let's go back to discussing the types. So there are 4 different integer types: int8, int16, int32, and int64. So the number in these names has to do with the number of bits used to represent the integers. So we're talking about 8-bit integers, 16-bit integers, and so on. So if you want to know what the min and max numbers that can be represented in each of these forms, all you need to use is the int min and int max command. And so, if you issue those, say for int 8, you can find out what those ranges are. And so we can also use these words as a function that will convert into. So when we first run this command, you can see that down here, after we run the whos command, that val1 is stored in double precision format. So here's the class column that comes out of the whos command. And you can see that that number 9 takes 8 bytes to store it in double precision format. So, there's a lot of wasted bytes in there because we're just storing a simple integer in double precision. Now, if we take that variable and put it as an argument into the function int32, it will convert into a 32-bit integer format, and then I assign it to a new variable val2. And down here you can see in the result of the whos command that val2 now has class of int32, and well, that only takes 4 bytes. Remember that each byte is 8 bits, so 4 bytes will give you 32 bits. If I had done int8, it would come up as 2 bytes. You'd obviously need to make sure that 9 is in the range of 8-bit integers, and in fact it is. So this, the bytes column tells you how much storage is required. This attributes, we'll see that later. Neither of these variables have any attributes that need to be described. So one use for the integer formats is that it reduces the storage needed if you truly are storing integers. But we can also use this to simulate the operation of our algorithms in fixed point computation. So if you know that you're going to be doing computations on a computer that does not do floating point, then you can kind of check to see how things will work with a certain number of bits to store integers. Now MATLAB has an entire toolbox focused on doing that. So if you're really going to be doing that, you might want to check that out. Another type is called logical variables, and so basically they are stored as 0 or 1, and I guess I should have 1 or 0 to match up with true or false. So 1 represents true, 0 represents false, and we'll use these variables for making decisions in our program. So we'll do things like if this is true, then do that, or things like that. So having a logical type is useful. Character type, yet another type of variable that we can store. So if you want to assign a character string to a variable, you put the string inside single quotes. And MATLAB will store those in their ASCII format. So I'm not going to go into the details of ASCII. I assume that you've seen that in a previous class. So basically each ASCII character has an integer value, and so MATLAB will allow you to convert characters into those integer values. And because of this equivalence between characters and integers, we can actually do math with characters. So here's an example. So as I said, to store a character string, we put it inside single quotes. So there's the single quotes around a character string of CAT, and it echoes back because I didn't put a semicolon at the end. So it echoes back that the variable animal holds the character string cat. And I'd like to point out that notice how when it echoes it back, the character type variable is displayed flush. Whereas down here on the next line, we use the command int32. This has already been defined as a character variable, and so it's going to convert each character in the string into its ASCII value. So 99 is the ASCII value for lowercase c, 97 is the ASCII value for lowercase a, and I don't show it there, but 116 is the ASCII value for the character lowercase t. And notice that this actually returns an array of numbers. So this is actually a a row vector, a 1 by 3 row vector. But notice how compared to a character variable, this is actually indented. So it's very easy to tell which are character variables and which are numerical variables by looking at how they get displayed. Because we could assign the character 9. So I could actually create a variable that has all of this in it as characters, and if it were to display, it would display over there. All right, let's look at this issue of doing math with characters. So one thing I can do is I can actually convert the character A, or any other character string for that matter, into double precision variable. So we've already seen that A has ASCII value 97. So here, since I used int 32, this was being stored as a 32-bit integer. Here, I'd be storing still the number 97, but I'd be storing it in double format. And then I can take that double precision variable and add 1 to it and use the command character to convert it back into a character. So I would take the double precision 97 plus 1 gives me 98. Take 98, convert it into a character, and it gives me the character B. Notice it lines up, so I know that that's a character variable. And it just so happens that 98 is the ASCII value for B, so that's why we got a B. Now, we don't have to convert into double to do math. We can say the character A plus 2 and then evaluate it as a character. So this will internally do the arithmetic using the ASCII values, and then character converts it back. So I started with A, I added 2, and so I'm now, A, B, C. C is 2 away from A, and so that's where I'm at. So there's a lot of things that you can do with characters. You can, character strings, you can use them to label plots and things like that. You can accept input from users as character strings and so forth. So knowing how to deal with characters is a good part of knowing how to work with MATLAB. Okay, putting all those types away, we'll revisit them as necessary, but let's talk about numerical expressions. So we're mostly going to be talking about working on floating point numbers here, but some of this will work with integers as well. So a numerical expression is just a command that we use to compute from numbers, and those numbers could be put in directly or could be stored in variables. So these are pretty straightforward. We've got the plus, the negative, that means negation or subtraction. We've got multiplication, which is represented by star. We've got division, which is represented by the slash. Now, word of warning, there's another slash in the other direction. That has a special meaning when we get into matrix stuff, so I'm not even going to mention that right here other than what I just did. And then we've got exponentiation. So those are the key operations that we can use. But then there's a bunch of other commands that will do other things as well. And so we can combine these things together as well as with other functions that are defined not with symbols but with words. And we can create some very complicated computations, which is very nice. And one thing that you should know about is the order of precedence for these. So the list here is in the order of precedence from occurring first to last. So obviously, as is usually the case, parentheses trump everything else. And just a tip, sometimes I'm unsure, all right, what will be the order of this? Well, if I'm unsure, I will ensure that I put parentheses in to make sure it evaluates in the order that I'm expecting. And so sometimes my code ends up having more parentheses than would be necessary, but in my opinion, it's a nice thing to do because it leaves nothing to doubt as to how things are going to be evaluated. So we've already talked a little bit about the elementary functions. There's lots and lots of MATLAB functions. That's what makes MATLAB so powerful. These things are provided for your use, and there's help functions for those. And we've already seen that if we explore the MATLAB's elementary functions by just typing help MATLAB elfin, you'll get a list of the elementary functions that can be broken down into categories of trigonometric, exponential, and logarithmic, complex number operations, and then rounding and remainder. Doing things in MATLAB and learning what is available and what isn't available often boils down to simply asking yourself, I wonder, does MATLAB have a function to do ... and then you fill in the blank. And so you go to the help lists and you see if such a thing exists. We talked about the look for command, which can be used to sometimes find commands. But nowadays, if you just go and Google, so often I'll go to Google and I'll type in MATLAB and then one or more keywords that relate to the concept that I'm trying to find. So I might go Google MATLAB transpose to see how does MATLAB transpose matrices and arrays. Well, we'll cover that in another set of notes, but right now, if you didn't know how to do that, you could Google that, and I'm sure you would be seconds away from finding an answer to that. And again, I just encourage you to poke around, look in the help, go to the documentation that's built right into MATLAB, poke around and look to see what they've got. It's all categorized in various categories, so it makes a lot of sense. There are a few special constants that MATLAB provides to you. Probably the most important one is pi. It gives you pi. Notice I say ... to double precision. So remember, that's to a degree of 2 to the minus 52. You can also represent the imaginary number with either the variable I or j. Electrical and computer engineers like to use j. All right, let's see if I can. Okay, I'm back from having that phone call interrupt. EEs and COEs use J, and the physicists, mathematicians use I. So you can use either one. Just be careful that we often use I and J for indices. So if you've already defined I and J for an index for doing like a loop, which we'll talk about later, you have invalidated it from being used for the imaginary number. So you do have to keep that in mind. MATLAB actually has INF, which represents infinity. So if you actually go to the command line and type in 1 divided by 0, it will return the value INF. So that's kind of cool in that it will account for that. And then related to that, there's also NaN, or NaN, which stands for not a number. And so if you go to the command line and type in 0 divided by 0, you'll get a return of NaN. And there are some other commands that will give you both infinite or NaN. And so these are handy, but sometimes you have to worry about these things. So you may be getting results that you think are numbers that are going to end up being one or the other of these things. And so sometimes you need to put in special commands in your program to test for this or strip these things out. And we've got some relational operators. So we already talked about arithmetic operators. or arithmetic operators, but these are relational operators. And they're all pretty straightforward. Greater than, less than, greater than or equal to, less than or equal to. And notice that we have to use double equal sign to represent equal to, because we're not assigning. Remember, the equal sign is assigning. So everything on the right, if it evaluates properly, gets assigned to something on the left if it is an appropriate representation of a variable. And then we have not equal to. So you can use these to test things. And the result of the test will be a logical value. So it's going to be a 1 or a 0. So we can test 3 less than 5 and we get back an answer of 1. Or is 2 greater than 9 and we get back an answer of 0. And if we use the command class, we can test the type of variable that we're getting returned. And we see that it is logical. Equivalently, we could have run the whos command and we would have gotten a list of our variables, and at this point we would have had a variable called ans, which is the default variable. If you don't assign something to a variable, it automatically gets assigned to the variable ans, which stands for answer. So that's how relational operators work, and we can use that. I mean, it's kind of silly when we're applying that to numbers that we type directly in, but we could be using this to compare, some variable value to some other variable value, and when one is less than the other, we do one thing, and when it's the other way around, we do something else. So these can be used to control how our program works in different situations. And then we've got logical operators that allows us to combine logical results. So if we go back to this page, we might want to do, when x is greater than y and z is not equal to 10. So how do we combine that? Well, there was an and, or it could be an or. So if you're familiar with logical operations, and I'm going to assume that you are, that you've gone through like a digital logic class or something like that, we can do the not command, the or command, the and command, and the XOR command. I guess I didn't format this far enough to get that turned into black rather than white. So here's our two variables, x and y. And we're just going through a truth table. I happen to start with 1, 1 and go down to 0, 0. So the reverse of what you might be familiar with from a standard logic table. So not x is just reversing what we had for x. So the double bar, just typing the vertical bar twice, in between x and y gives us the OR function. And then using double AND gives us the AND function. And then to get XOR, we have a named function that takes the two variables as arguments to that function. And you can see over here on the right doing a little test. So I'm doing 2 less than 4 or A equals C. So you can see that, well, 2 is less than 4, so we got a 1 on that side. A is not equal to C, so we got a 0 on that side. So 1 or with 0, that would be this command, or that line there. We get a 1 as our result, and so we get that as our result. So test 1 was 1. Here we do an exclusive OR, 3 less than 5. Well, that's true. A less than C. So remember, characters are represented and evaluated in situations like this in terms of their ASCII values. So A is less than C, so we get a 1, 1. So the exclusive OR of 1, 1 on this line is 0. And then you can check to see that the results of the logical operators are, not surprisingly, logical class variables. And there is a well-defined order of precedence here. So you can see up here that there might be a little bit of confusion as to how these things work, but we do our relational operations first before we do the logical operators. And so you can see that relational operators happen before the logical operators. It's a little clearer with XOR, since those would happen inside the parentheses and separated by commas. So it's a little clearer how that works. That's why XOR is not on this list. So this finishes our little discussion here that went over how to evaluate variables and assign variables and logical operators and types and class and double precision and all that stuff. So in the next set of notes, we'll dive even deeper into MATLAB. So we'll see you next time.